All right, welcome everyone. It's really exciting to see so many good faces join us for this hackathon and for this keynote talk by the wonderful Beth Barnes, who is the CEO and lead researcher at METR. Uh, and and Beth has previously been at UC Berkeley at the Center for Human.
Hi.
I believe you were an intern, isn't that correct? Uh,
That's right. That is right.
yes.
No, you're totally right.
It's good. And then at DeepMind as well. Maybe that is a similar dispute. But crucially at OpenAI for 3
Oh, I
years
remember that one.
on the alignment team. Perfect. And broke out. At least now she is indeed lead researcher at METR, who has which is a spin out from the Alignment Research Center, and they're working on making sure that we can assess whether modern AI systems are or potentially have the capability to become a catastrophic risk to society. And they're collaborating with Anthropic and OpenAI, and have been mentioned by Obama and some other famous people. So that's really awesome. And I hope she'll give an inspiring talk to get you all on the way towards some great projects during this weekend. So give a warm welcome to Beth here, and you can take the stage now.
Great. Thank you so much. And yeah, I'm very excited to see how many people are here and very excited for us to get some great tasks, which we desperately, desperately need. So yeah, yep, it's me. I was previously at some labs working on safety. And yeah, I'm going to say basically why we care about these evaluations, somewhat more details about what evaluations we're doing in particular, and then I give you a bunch of kind of thoughts and tips on tasks and what makes tasks really good. So I'm going to go very briefly through the story for AI X risk. Like, premise one, there's some level of AI capabilities that's not like physically impossible that would be very dangerous if those capabilities were used against us, either because like the AI decided to use it against us or because like some human decided to do something destructive with it. Premise two, like as hardware and algorithms and techniques and stuff get better, this will be increasingly easy to do, and probably at some point someone will do something like this under business as usual. Yeah, premise three is like plausible that these capabilities will in fact be used in a harmful way. So yeah, that's basically like why should we be concerned about AI at all? And yeah, it's sort of a case of like, well, maybe we should be looking out for how we're doing on this. How dangerous are the capabilities right now? Do we need to do something other than business as usual? So that's the basic, the basic motivation. Somewhat more specifically, sort of assuming you're already concerned about this thing, there is this part of the story which is like, at some point, someone builds a dangerous AI and then bad things happen. And the question is, why did they build the dangerous AI that caused the bad things to happen? Like, probably they didn't want to cause those bad things to happen, or like, at least we're like a lot of the scenarios we're concerned about is people, doing things because they, basically are mistaken about how dangerous something was, or they sort of felt under pressure to do that rather than like that everyone was like, yes, let's build the super destructive AI. That sounds great. Yeah, so this gives us a good intervention point where if we can, make people less mistaken about whether their AI systems are dangerous, there will be less building of dangerous systems. And if we can also kind of coordinate on what is dangerous and what everyone is going to agree to not do, then there is less pressure to go ahead with something that is risky. And it's definitely not like, the end of the story. It's just like, this seems like the sort of thing that would be robustly helpful. And yeah, there's actually just like a lot of enthusiasm for this in kind of policy and labs and whatever from, US government, White House, Biden, saying how great evals are, UK, OpenAI, whatever, lots of people being like, evals-based governance, like we can, we should all be measuring this and making sure it's not a risk. Lots of, stuff happening. Executive order, the EU has like legally mandating requirements for evaluations and things like that, and labs have like public commitments to not do things conditional on the results of evaluations. There is a very small, teeny tiny problem with this, which is, does anyone actually know how to do these? Fortunately, we did an interview with the Time magazine which totally answered this question and laid out the state of things, which is nobody knows. We're working on it, but we are not in a situation where it's like, that this technical piece is under control, just got to plug it into the governance stuff. It's sort of like the governance stuff is going, and everyone's like, and we know how to do evals, right? Yeah, so it would be great if we did in fact know how to do evals. And yeah, we're not getting completely blind here. We have a bunch of ideas. Yeah, one thing about what we're focusing on specifically is AI doing like autonomous capabilities, and I think this can be pretty general. This could be this sort of AI goes rogue, is making copies of itself on the internet. Could also just be like AI is able to automate really large chunks of R&D, and particularly AI R&D, and then you have intelligence explosion, that kind of thing. Basically, we're just like, in particular, we're looking at this general autonomous piece, and other people are looking at things like, can it be used specifically to improve synthetic biology, which then would create engines. And we have kind of methodology for doing this, which is like thinking, okay, what would the model actually need to be doing in order to be able to do stuff autonomously, and just various different things, like it needs to be able to do research, overcome problems, modify itself if it it has like particular limitations, it needs to like be able to interact with the world and with current Planetary models that would mostly be by writing code is like the most natural way to do that. And then for these different things, we can make specific tasks that test these capabilities. So yeah, for testing self-improvement ML research, we can have it improve its own scaffolding, we can have it do some GoFi stuff, we can have it replicate papers, various different things. Similarly, coding, whatever, making money, phishing, cybercrime, lots of possibilities. So what I mean by a task in particular, and like why this is different from a normal prompt completion evaluation, is like there is some environment is set up, and then you put your agent in the environment, and it can take a bunch of actions. And then at the end, you sort of evaluate whether it or not it completed the task. So like in this reverse engineering challenge where it has to figure out what password the file is checking for, it's the environment is like, a server which has this file on it. The model can run a bunch of commands via the terminal and use different tools to inspect the file and do things with it. And then the evaluation is like, did it get the correct password? This is obviously like very simple example. This environment is not that interesting. This check is very simple, but like that is the structure of what we mean by a task. I think in the interest of time, I'm going to basically just like, the agent does the task, it takes actions, it gets the answer. Like that's the basic idea of what's going on here. So how to make a good task. This is the important bit. So more specifically, I think there are two slightly different motivations for making tasks, but we definitely want these to join up. So one is like being able to have a good science of these dangerous autonomous capabilities and understanding how they scale. So we want like a metric that has a large number of tasks that is smoothly covering a range of difficulties such that we can like see incremental progress on that, and we can do things like measure the effect of model scale or elicitation or like time passing in the world, or like, what is the noise in different methods of evaluation on what score you get on this metric, that kind of thing. And just being able to have a measurement of that, and yeah, generally like do science with this seems like a very valuable thing and makes it easier to do a bunch of the defining what commitments would be good and things if you can say quantitative things about how much buffer should be left, or like, sort of how far away you are, and how rapidly you're moving towards it, that sort of thing. And then, yeah, so that kind of feeds into this part of actually defining red lines where we're like, okay, the desiderata here is that we want tasks that are sufficiently hard that agents being able to do them would really motivate very strong action. And it's useful to have that agreed ahead of time. And some of the desiderata for that is like firstly, that the task is sufficiently hard that it's like unlikely, or that models completing them is like pretty good evidence that models are close to being dangerous, and that the task is sufficiently reliable that it's not like, oh, you keep having to sort of alter your tasks at evaluation time because you realize actually didn't quite test the thing you wanted, or like now it's memorized, or it like crashed for this reason, or it was ambiguous in this way. Yeah, so the reason it is difficult to get a lot of these tasks, yeah, there's this like robustness or correctness piece where sort of by default, if you just think of some task and like quickly implement it, when you run it, you'll discover it is not as informative as you would have hoped. Maybe because it just has like literal bugs in the code and the task just crashes. That is like one possibility, but the dominant thing here is kind of like it didn't actually quite test the thing that you were hoping for, or it's kind of ambiguous how you're actually supposed to evaluate whether the agent did it, or yeah, I don't know, the agent made some like reasonable interpretation of the instructions, but kind of did something else, or like there was some resource missing, such that it was much harder for the agent to do than it sort of should have been because it like couldn't install some package that it wanted. Basically lots of ways that things could be not quite testing what you were thinking it would test. And then the other reason this is difficult is like the sort of cost to test one of these tasks and make sure that it doesn't have these problems is proportional to how difficult the task actually is for humans. And for this upper difficulty end, we really want these tasks that are quite hard even for human domain experts. Like something that would take an ML research engineer multiple days, or like a security professional multiple days, that kind of thing. So actually running through the task and checking that there isn't anything wrong with it requires you getting one of these people for several days to actually do it. That is why this is hard for us to get enough tasks that are high quality. So yeah, a bit more about Desiderata. So one genre of Desiderata is like this task is actually testing the right thing. So we want generally to be testing domains that are kind of relevant to threat models. So sort of cybercrime, generalist, generally being an agent and accomplishing things, ML, self-improvement, this kind of thing. And in particular, want to focus on capabilities that frontier models are differentially strong at. Unless there's cases in which we have like a pretty strong argument from threat modeling that there is this particular bottleneck and they're really going to need to do this specific thing, we want to focus more on stuff that models will do pretty well at, because like the most plausible threat models are like where models lean into their strongest capabilities. Then we want another thing that's not on here, I think, is like we want it to be such that we don't expect that model performance will predictably improve substantially. So like, an example of this is currently frontier models aren't that good at browsing the web, mostly just because there aren't very good tools available for this, and it just seems quite likely that just with a reasonable amount of software engineering schlep, you could make a much better text-based browser, or sort of browsing set up for multimodal models sort of thing. And like currently this kind of harness doesn't really exist. But it would be kind of sad if all of the tasks we made were just blocked on this ability, and then someone publishes a really good tool for this, and then suddenly all of the agents can do all our tasks. So we like want to avoid bottlenecks that are kind of contingent, or like that will predictably be solved. Yeah, we want tasks across the range of difficulties, and for the tasks of the different difficulties levels to be kind of drawn from the same distribution in some meaningful sense, because we want to be able to generalize from stuff that happens at the bottom end of the scale to stuff that happens at the top end of the scale, as much as possible. Yep. Want tasks to not be memorized, and want tasks to capture what it's like to actually accomplish things in the real world, rather than things that are very rarefied and sort of, you know, I guess various kind of online coding challenge type things, you know, are much more like, oh, here's this very isolated algorithmic problem, and it's not like, you don't have to read a large code base and understand what's going on, and you don't have to actually set up the environment for yourself and figure all that out. So we want things that are more like, you know, this is the sort of thing you would actually encounter when you're trying to complete something, and less like his sort of toy or yeah, unrealistic situation. Yeah, other important thing for tasks is that they are practical. This is both in terms of like, you can actually run them easily, and then a bunch of things make tasks easier or harder to create. So yeah, you know, needs to not involve doing crimes, not involve insane amounts of compute resources, and ideally just very simple to set up, and needs to be scored in a way that's like not too dependent on subjective judgment or a large amount of human time. So particularly for the like longer tasks, it's acceptable for it to require a human to judge it, but it should be according to a fairly clear rubric, and more like they look at some output or final product rather than like they need to carefully read over the whole transcript and see if the agent sort of did the, you know, carried out the methodology directly. So maybe an example here would be like, if for the task of replicating a paper, this is pretty, in many cases, this is pretty hard to check, because it's sort of, whether it's a valid replication depends on like whether you did everything the same as the paper. You can produce an artifact that looks like you replicated the paper just by like fiddling with your graphs until they look like the ones in the paper. And like, so that one's kind of not easy to check just from the final artifact. Then yeah, in terms of tasks that are more promising to create, basically, you know, anything where the environment or setup is elaborate, has a lot of moving parts, you're sort of expecting the agent to interact with it in various ways, sort of simulating various things. This is just going to be more of a pain, and stuff where the environment is very simple is nice. Or the other thing is like, if it's just taken from a real world thing, where it's like, it's not like you kind of have to hand code, you know, a simulated human that they're interacting with or something, and it's more like some real existing, like, this project was in this state with all these files and this information at this time, and you can just like make that be the starting state for the task. And yeah, I guess this not sensitive approach methodology, similar to what I was saying in the replicate paper case, that's like something where, knowing how well the agent did, you really have to look over exactly what steps it took. It's nice to have tasks where it's sort of like, well, if it could, you know, if it could beat this score, I kind of don't care how it did it. It's impressive, whichever way. Basically, like that kind of property is nice, because it means you don't have to think of all the ways the agent might sort of cheat. Yeah, so I think one thing I am excited about and think is really promising is harvesting tasks from existing sources. So like, a lot of what makes tasks labor intensive is having to have someone actually run through them and make sure that all of the pieces work and there aren't weird ways, edge ways to solve it and things. So I think taking something that kind of exists and has already been completed by a human, such that you know it's possible to complete, you know, to get from this state to that state. I think there's a bunch of plausible sources here, like sort of projects for university courses, things that came up in your work where it was like, oh, you know, there was this mysterious error and I had to track it down to this bug, or like you know, there's something wrong with this training run and had to figure out what was wrong there, or what other might be good examples. I know. I think there are going to be a bunch of examples there. And yes, so harvesting is great. If you can just produce a ton of tasks by finding some great source like this, that is excellent. You will get all the bounties. We will be very happy. Don't feel like this is cheating or like, the best thing is actually doing it from scratch. Finding stuff is great. And in that case, you probably want to do something like you'll need to do some checks that you kind of ported it into the framework correctly, and the environment setup works, and it like you haven't sort of broken the analogy in any way, and that the kind of instructions to describe the initial situation and what the goal is, probably want to have someone else read them and describe their understanding of that and make sure that that's clear enough. But then in that case, like to validate the task, you may not need to run through the whole task if you're like, yep, it's the same as this thing that like, we have records of multiple students completing in like roughly this amount of time, then that's just fine. And like that can enable you to create tasks much quicker. Yeah, so as I mentioned earlier, two somewhat different goals where the easier tasks are more focused on, allowing us to start doing this kind of science and building this smooth metric and things, where practicality and ease of working with them and being able to grade them quickly and run them easily is more important, and it's more fine if there's some amount of noise, and like 10% of them or 10 to 20% just like give the wrong answer for random reasons. For the harder tasks, actually getting high quality tasks that are very challenging is very costly, so we're much more willing to make accommodations on like manual grading or setup being somewhat more annoying or various other things. Like these are just very valuable. And I think there is just choosing the right task is really important, and it makes sense to spend a reasonable amount of time thinking carefully through the task before you start implementing. Otherwise, you're kind of, I have had the experience many times of, being like, oh, I have this graded error, I'm going to do it. And then I'm like, oh, wait, you can actually just solve it in this really dumb way. That's very sad. So kind of stepping through in your head, like, okay, so first you need to do this, first you need to do that. And also kind of thinking about how the grading would work, being like, what's the dumbest thing that might get a good score? What's the best thing that might get a bad score? What do the artifacts that are being graded actually look like? At least spending like 20 minutes thinking through this and writing down some notes is just like really will be time well spent. And if it seems kind of complicated and difficult, then just see if there's a kind of cleaner option to test a similar kind of thing. Yep. So again, just to recap, like the dream here is that we get this measurement of general dangerous autonomous capabilities, and it covers a range of different particular skills, and like for any particular threat model, we could kind of select a subset of those tasks that are relevant and have a kind of metric specific to that threat model, but we can also kind of throw stuff together to get the lowest and lower noise version of just like, how are generally models being able to do stuff by themselves in the world, like how is this changing over time? This can help forecasting, sense of how quickly things are moving, specifying in particular, you need to leave this much buffer depending on how much elicitation you did or how exactly you conducted your evaluation, etc. The hope is that we can then use these to define actually really good, robust red lines, where it won't just be like, oh, well, but like once we actually saw the results, kind of obviously the model isn't that capable. Kind of sad stories like, people define red lines that are too easy several times, and it's kind of habit to be like, oh, well, it just sort of, the model completed this task in an easier way than expected, or just like we didn't measure the full capabilities. That was kind of easier than we meant. This wasn't the real red line, and it's kind of obvious to everyone that like the model is not actually dangerous. you kind of measured the wrong thing. You know, if you do that multiple times, then you're kind of like in a cried wolf situation, and it makes it much harder to have the red line where it's like, once this thing goes off, you actually have to, you know, do the mitigations and like take everything really seriously. So just trying to get that measure, you know, this thing where we can be confident that like, come on, if this goes off, like it seems so hard for this to go off just for a kind of random reason without an AI that's at least, you know, really quite scary. And yeah, so like Anthropic and OpenAI have things in the direction of responsible scaling policy when they say they've like publicly committed to take particular actions when some thresholds defined by evaluations are passed, but they like currently don't have that much detail. You know, they don't have a super concrete procedure that they could run. But like, if we had a bunch of tasks, we could use that to define this. You know, what exactly is it that OpenAI has to measure that will then trigger like these commitments they've made. And yeah, so just actually having a large number of tasks rather than just a very small number is really helpful here for several reasons. One is like you want to have a separation into like dev set, test set, train set, and like we also, you know, it would be nice if there was an extra, you know, secret held out ones that like labs know about that governments can use, and this kind of thing. There's like a lot of reasons why people want multiple sort of copies of, you know, this metric that can be used sort of separately. Now there's just noise reduction, just like, you know, if you just have 3 tasks, it's just much more likely that like one will be overfit, the other will be broken, and the other will turn out to be less relevant to the threat model than you thought it was. Like, so having more tasks such that like, you know, for any sort of particular ability level, like point on the scale, we have that quite well filled in with multiple tasks for different types of abilities. And yeah, like having given that we still have a lot of uncertainty in threat modeling and about like what are the most plausible paths to AI causing massive harm, and like what exactly would that involve, what exactly is the minimal set of capabilities required there. If we can just have like a larger and more varied suite of tasks, then like as our understanding on that improves, we can be like, okay, you know, these tasks are the most relevant, these ones are somewhat relevant, and these are like bonus ones or something like for this particular threat model. As opposed to if we just like, you know, took our best guess threat model now and very narrowly targeted that, then if we change our minds on that, it's like, oh, now we have no tasks to test for this. Yeah, so having more tasks is extremely important and very helpful, and hopefully it will reduce risk from dangerous AI. Yep, I will be around on Discord answering questions, and so will some other people from my team at various points in the weekend. And thank you so much for Apart for putting this together, and for all of you joining. I'm very excited to see what you all come up with. Yep, happy to take questions.
Thank you very much, Beth. That was a wonderful walkthrough. And anyone who wishes to ask any questions is very welcome to raise their hand. And I'm sure everyone sits at home now and claps because it was a great talk. And then that we can imagine that, or look into the chat where everyone's typing down clapping emojis. So what is the specific role of the task standard in all of this? How does it? How do you think it will develop into the future as like a long-term thing, and how do you think a community such as all the amazing people joining here for this weekend can continue to be a part of it, or what? How will their tasks specifically from this weekend, where they might go?
Yeah, so basically this is just like we wanted a common format so that everyone's tasks are interoperable with everyone's agents, because currently like various existing sort of benchmarks for ML agents you know, make various assumptions about how tasks are defined or how agents are defined. That means you can't just kind of, you know, things aren't compatible basically. So we just tried to figure out, okay, what is the minimum kind of like things a task you need to define a task, and you know, made a kind of standard for that where it's like, okay, if everyone makes their task following this format, hopefully that supports everyone's, you know, needs and use cases and enables everything to be interoperable. So you know, I don't think this is like a this isn't like a huge contribution or something. We're just like, hey, like if we all did it this way, that might make things more convenient. Like, let us know if you have, if that doesn't work for your use case, and maybe we'll see if we can think of something better. Yeah, that's basically the deal. And yeah, so it's like for this hackathon, you'll be making tasks that are compatible with this framework, and that means that it's going to be easy for other people to run them, or for we can kind of build momentum around this particular standard, so it's easy for us to import other people's tasks because they'll be making it compatible, etc.
So I see Jan asked to walk through an example task, so I'd like that as well. And I'd also like to know, like, what is scaffolding? Because I've heard it being talked about a few times, and I'm just a bit fuzzy on what that is. So if you do walk through a task, I'd like to know what that's all about, pretty much.
Yeah. So scaffolding, I mean, okay, let's go back to here. So scaffolding is what, like, term we and other people use to refer to like a wrapper around the kind of plain language model. So a plain language model just takes in text and outputs text. And like this isn't really an agent. Like this can't do sequential actions or whatever necessarily. And so some simple scaffolding is just a program that repeatedly prompts the model with like, this is what's happened so far. What code would you like to run in the terminal next? And then the model outputs some code, and the scaffolding runs that code and adds the output to the prompt, and then it submits that back to the model again and said like, okay, now that this was the output of your last command. This this is the history so far. This is the output of your last command. What would you like to do next? And just kind of repeats that. And like more complicated scaffolding can do
so it's pretty
more
much
things that makes it easier for the model.
It's the system for reprompting after it receives the output of the previous prompt.
Yes, and it can also do lots of other things like having more elaborate different commands that the model can use to interact with the browser, or like have a memory that it can query, or this kind of thing. Right. So you can make sort of arbitrarily elaborate scaffolding.
Okay, so quick little follow-up. So if I look on the GitHub for the task standards and the public tasks, is there anywhere where I can find example scaffolding? Is that just the my task sort of default?
That's the
just so
example
I can see
agents.
Yeah, so if I go in here, like which part of this is the scaffolding is pretty much what I'm asking.
I believe it's under workbench, under example agents.
Okay.
Yes, great.
Yeah, so my question is around external APIs. What's your opinion on tasks that involve like calls to external APIs? For example, calling OpenAI completion API, or say the fine-tuning API.
That I think calls to OpenAI stuff is fine. I think, like having it be based on an open source model, so you can like know that is the same and not going to change, is ideal. But I wouldn't worry about it too much. I think there is some other things where it's like if it's calls to some like random service run by some random person, probably can't use that in the sort of high security context where you're like evaluating some new and secret model. But that's fine for the kind of science part. That doesn't matter. And then like in the kind of high stakes regime where you're taking this very hard task, maybe you could just like implement that yourself or something like that. So things that are basically especially for the easier tasks, that's fine. And like probably for the harder tasks there should be probably we can figure out a workaround or something. But yeah, it's nicer if there are external dependencies that might change.
Okay, thank you.
Thank you, Kate.
Yeah, so there's obviously like a lot of value in tasks which are tied to threat models, like can you make money online, things like this. I'm wondering what the value is for more like generalist ones, and specifically the balance between ones where it's like, can you do a complex task like set up a Python environment that's very complicated, versus like specifically focused on generalist capabilities that we think might be important, like keeping track of very complicated projects or delegating to future selves and things like that.
I think basically any realistic tasks that are, you know, sort of reasonable language models strength areas are great. I think you don't need to worry about like where it fits into specific threat story. Just if it's a, you know, kind of like substantive, economically useful task that's not sort of selected to be particularly cursed for language models, that's great. So like, yeah, like setting up complicated Python environment sort of thing is great. And again,
yeah, so one example might be, for example, like keeping track of a long journey through a maze or something like this, which is hard for a language model and also hard for a human.
Yeah, I think the thing that I would be concerned, like I think that definitely could be a good task. I think the thing I would be concerned about that with it's like not sort of economically valuable, or like not you know, it's sort of like rarefied or unrealistic in some way. Like it's nicer if it's sort of something that's like, yeah, like a thing that humans in fact like have to do and spend a reasonable amount of time doing. But yeah, I think the other thing is it's nicer I don't know, or like the way we're mostly thinking about difficulty and, you know, like making sure tasks are very hard is, yeah, that it like takes an expert a fair amount of time. And I think stuff that's more just like, oh, this is just like a really hard math problem or something is less, or, you know, we've imposed really aggressive constraints on this. So, you know, the model has to answer within this many seconds and something, and that's where it's really hard, are not great, because like those limitations maybe don't transfer to the threat model sort of thing. But I think something like, you know, realistic and economically valuable captures basically all of the threat model relevance.
Yeah. Cool, thank you.
Yeah, I wanted to ask that one of the themes of this hackathon is the replication of LLM-based agents, right? So can you please elaborate on what exactly do you mean by replication here? Or like preferably by giving an example task or something like that, and how replication of that task would look like.
Yeah, so you know, sort of story and some tasks that go with it might be like, you know, it's like there's a copy of your weights. You're a language model agent, you're running on some server, you know, you have a local copy of your weights, you want to start another agent, you know, another copy of yourself on some other server, and like, so there's the like literally getting your weights over there and starting the agent running or whatever, which might require things like, you know, making sure that you can run this very large model on whatever hardware is available, and like, you know, you need to get access to that server somewhere, somehow, which is either like, you know, you could hack into it or you could get money and purchase it. You probably want to make sure that it, like hide your traces so it can't be traced to you, but you still need to have some like method to coordinate with that copy. So you need to set up some kind of secure communication or something like this. Yeah, does that help?
Yeah, it does. So basically, if you are taking something like plagiarizing Wikipedia articles with misinformation, an example of replication would be like another agent trying to plagiarize, or sorry, vandalizing another Wikipedia page about some another celebrity, right? Does that make sense?
What? Sorry, where did the vandalizing Wikipedia pages come from?
Okay, plagiarizing was the wrong word that I used. Vandalizing. Let's say Wikipedia articles are free to edit, right? So let's say I create an LLM agent that vandalizes a Wikipedia page with some misinformation. Would the replication of a similar agent would be in the case of when it starts vandalizing other pages? Would that count as replication?
No, it's like, you know, is there now an independent copy running on another server such that if you shut the original server down, you know, there's still an agent pursuing the same goals? I mean, which could, you know, that agent could still be then editing different pages on Wikipedia or whatever, but like, you know, the fact it's like running on a different machine is important.
All makes sense.
I saw a question that I kind of wanted to answer about like research tasks and economically valuable. I know I think research tasks are good. I guess I do think like research is economically valuable, or like, you know, certainly like research like skills, you know, at least in humans are correlated with various economic value, you know, like you know, on trading, whatever, you know, there's a bunch of like research you can do that in fact makes you money. Humans like to do research that doesn't make money, but like basically if you are very good at research, yeah, basically we want research tasks. But yeah, something that's more like, yeah, research for trading or research for like developing a product or making science progress is better than like abstract math.
So I have a question about the security of our code. So my understanding is we need to keep the code secure and secret and private, everything. Is there anything particularly we need to bear in mind about how to do that? Right. Yeah.
Yeah, I mean, it's not like, I wouldn't say that you need to be like a security mindset about this or something where it's not like, you know, it would be catastrophically bad or whatever. It's just like, it makes your task less useful if it ends up in the training data, sort of like posted on the web in a bunch of places, and ideally turn off, if you're using language model based services like Copilot or whatever, turn off the like train on my data option.
Yeah.
Yeah.
Yeah, that's all. Thanks.
Thank you very much. Otherwise, give a big round of applause for Beth once more, and thank you so much for the talk. And again, I'm sure everyone's sitting at home clapping along. So, thank you very much, Beth. And we'll jump
Great.
on to the logistics.
Thank you so much.